Greetings and welcome to Part A of the walkthrough for the SASMO 2020 paper for Sec 3 students. SASMO stands for the Singapore and Asian Schools Math Olympiad. In total, there are 25 questions. The first 15 questions are MCQ questions. You get 2 marks for each correct answer and you lose 1 mark for every wrong answer. The next 10 questions are 4 marks for each correct answer. There are no marks penalized for wrong answers. These are open-ended questions. More information can be found about this competition at their website that I will link in the info section below. In this video, I'll be going through the questions and solutions for the first 15 questions. You can find out the questions and solutions for the last 10 questions in Part B of this video. So let's begin with question 1. Find the value of the following. 2020 times 2020, subtract 2020 times 20 plus 2020. Pause the video here and give this question a good try. Okay, in case this is not apparent, calculators are strictly not allowed for this competition like most Olympiads. So let's go through the answer. First, we can factorize out a 2020, that will leave us in brackets 2020 minus 20 plus 1. Then when you subtract and add that together, you'll get 2001, and we'll split the 2001 into 2000 plus 1 and expand it back again. So when you multiply by 2000, you'll get 4,040,000, and when you multiply by 1, you get 2020. You can add those two numbers together easily. You'll get 4,042,020 as the final answer. Question number 2. Looking at these 5 possible options, which of the following has the largest value? Pause the video here and give this question a good try. Now, the first and most obvious thing is that A is so much smaller than C, so we can eliminate away option A. And if we look at option B, we can simplify this. We can use our Indice law and subtract the exponent. We'll get 2020 to the power of 2. When you square it, you'll get the exact same value as C. Now, that means that we can eliminate B and C because option E would then be a better choice. And we just have to compare option D versus one of option B or C. And I would prefer to compare it against option B. The reason is I can cross multiply the denominators, and we can just compare the numerators. So the numerators that we will get is 2020 to the power of 38 minus 2020 to the power of 19 versus 2020 to the power of 38 minus 2020 to the power of 21. Now 2020 to the power of 21 is a larger exponent than 2020 to the power of 19. Since there's a larger exponent, you're subtracting by a larger number, then the first expression has to be larger than the second expression. So we'll eliminate option E, and D will be our final answer. Question number 3. Find the number of trailing zeros for 11 factorial minus 10 factorial. Pause the video here and give this question a good try. So for 11 factorial minus 10 factorial, we can factorize out 10 factorial, leaving us 11 minus 1 in the brackets, and that's just 10. So we just need to count the trailing zeros for 10 factorial and 10. 10 has 1 trailing zero. 10 factorial can be expressed as 10 times 9 times 8 times all the way to 5 times 4 times 3 times 2 times 1. And we want to see how many 10s there are. There's obviously a 10 at the start, and there's a 5 and a 2, which also multiplies to give us 10. So altogether, we have 10 times 10 times 10, which is 1000. Therefore, there will only be 3 trailing zeros. Question number 4. Find the value of 2025 times 19 factorial squared minus 5 times 19 factorial squared, all divided by 100 times 18 factorial times 20 factorial plus 18 factorial times 20 factorial. Pause the video here and give this question a good try. So for question 4, we can first observe that there's a common factor of 19 factorial squared colored in red in the numerator, as well as a common factor of 18 factorial and 20 factorial in the denominator. So let's factorize them out first. And if we simplify it, we'll be left with 19 factorial squared times 2020 in the numerator, and 18 factorial times 20 factorial times 101. So what we can do here is one of the 19 factorials, we can split it into 18 factorial times 19, and the 20 factorial in the denominator will split it to 19 factorial times 20. 2020 can be factorized into 20 times 101. And this is nice because we have a lot of common factors that we can cancel from the numerator and the denominator. This leaves behind only 19, which is our final answer. Question number 5. Which number below is a factor of 91 to the power of 4 minus 1? Pause the video here and give this question a good try. So for question 5, we're going to apply the quadratic identity that the difference of square a square minus b square is equals to a minus b times a plus b. So we're going to treat 91 to the power of 4 minus 1 as a a square minus b square. And we can factorize it to get 91 square minus 1 times 91 square plus 1. Then we can do the same again for 91 square minus 1. So we'll take the difference of square formula and factorize. So it gives us 91 minus 1 times 91 plus 1 times 91 squared plus 1. And we can evaluate all the three terms inside the brackets. That will give us 90 times 92 times 8,282. Now 90, we can split it up to 9 times 10. 92 is 46 times 2. And 8,282 is 82 times 101. And I've split it up this way because I want these three numbers highlighted in red. 10, 2, and 101 because they multiply together to get 2020, and that's our final answer. Question number 7. 4 friends have accounts in some social network. Any 2 of them use at least one common social network and no network is used by more than 2 of them. At least how many social networks are used by the friends? Pause the video here and give this question a good try. Now we can solve this question using some simple graph theory. We're going to represent the 4 friends with 4 nodes. And we're going to use edges to represent the social network. So let's combine 2 of these friends with this orange network. So you can see that this orange line connects 2 friends. That means we can't use this social network anymore since no network is used by more than 2 of them. That means if we connect every friend to every other friend, you see that we need 6 different social networks. So the final answer is 6. Question number 8. The value of function x given by ax squared plus bx plus c is 0 when x is equals to negative 1. Given that the difference f2 minus f1 is equals to 11 and f3 minus f2 is equals to 15, what is the value of a plus b plus c? Pause the video here and give this question a good try. So what we can first do is we can substitute x equals to negative 1 into the function. This will give us a minus b plus c, and we know that this is equals to 0. Let's call this equation 1. Then we'll find the difference f2 minus f1. We'll substitute in x equals to 2 and minus away we substitute x equals to 1. This will give us 11, and we can simplify this equation. This will give us 3a plus b equals to 11. Let's call this equation 2. And lastly, we'll do the same for f3 minus f2. This will give us 5a plus b equals to 15. Now we can subtract equation 2 away from equation 3. This will give us 2a equals to 4. That tells us that a must be equals to 2 and b equals to 5. And we can substitute these 2 values into equation 1. That will tell us c equals to 3. So a plus b plus c will be equals to 2 plus 5 plus 3, which is 10. Question number 9. We have a number pattern here. We have a sequence of 16, 37, 58, 89, 145, 42. What is the next number? Pause the video here and give this question a good try. So this number pattern is a digital sum of squares. What happens is that we take the number 16 and we split it up to the digits 1 and 6. We square them and we add them up that gives us 37. Same thing for 37, we split it up into 3 and 7 and we square both, add them together, that gives us 58. And you can see that this pattern will continue. And from 42, we'll take 42, split it into 4 and 2, square them, add them together. The next number in this sequence will be 20. Question number 10. There is one counterfeit coin among 2019 identical coins. The genuine coins have identical weight and the counterfeit coin is lighter. Andy wants to determine the counterfeit using a balance scale. There are no restrictions to the number of coins he can place on the pens each time. What is the least number of ways to find the counterfeit coin? Pause the video here and give this question a good try. So for this question, let's start at the beginning. Let's look at round 1 and look at a hypothetical situation here. What if we tried to spread the coins out into two equally distributed piles? So 1009 on each side of the weighing scale, and we have one coin left over. So in the best case scenario, the weighing scales are balanced. That means the one remaining coin has to be the counterfeit. That's the best case. But in the worst case scenario, the scales are tipped to one side. That means we still have 1009 coins to work with. That's not a good situation. So the strategy in this game is we want to minimize this worst case scenario. Can we lower this 1009 coins further down? So a better strategy is to divide the coins into 3 equal piles. This way, if the scales are balanced, the best case scenario is that it's the leftover pile of 673. And if the scales are not balanced, they're tipped to one side, the worst case scenario is also 673. So we've essentially cut down the number of counterfeit coins from 2019 to 673, no matter what. This way, for round 2, we can divide the 673 coins into 3 piles that are as evenly distributed as possible. You can see that now the worst case scenario is the leftover pile of 225, and the best case scenario when it tips to one side is 224. So we've cut down 673 possible coins down to 225, the worst case scenario. And we can continue this strategy in round 3. We divide it into 3 even piles. The worst case scenario is now 75. In round 4, we'll cut it down to 25. By round 5, we'll divide it to 889, so the worst case scenario is 9. By round 6, we'll cut it down to 3. And by round 7, we'll be down to 1 coin no matter what. So the answer is 7 rounds. Question number 11. How many 4-digit numbers have the digit 1 but not digit 2 among its digits? Pause the video here and give this question a good try. So in question 11, I've represented all the possible 4-digit numbers in the form of a Venn diagram. The first circle on the left represents all the 4-digit numbers that contain the digits 1, while the second circle on the right are all the 4-digit numbers that contains the digit 2. So first, we can count all the 4-digit numbers that do not have the number 1 and 2, and that's represented in the Venn diagram by the blue area. That will be in total 7 times 8 times 8 times 8. This is because the first digit cannot contain the numbers 0, 1, and 2, while the last 3 digits cannot contain the number 1 and 2. Therefore, that's 3,584 possibilities. Next, we can count the number of digits that do not contain the number 2 in it. So this would be represented by the blue area plus the red area. In total, that would be 8 times 9 times 9 times 9. That is because the first digit cannot contain the numbers 0 and 2, and the last 3 digits cannot contain the digit 2. So altogether, that would be 5,832. But what we really want to find are all the numbers that contain the digit 1 but not 2, and that's represented by the red area only. So what we can do is we can take the answer that we have found, 5,832, which is the blue area plus the red area, and subtract the blue area, which is 3,584. to get an answer of 2248. Question number 12. In the diagram, we have a triangle ABC where angle ABC is 90 degrees and DEFG is a square, such that point E and F lies on the hypotenuse AC. Given that AE is 4 units and EF is 6 units, find the area of the quadrilateral ACGD. Pause the video here and give this question a good try. Since we are told that DEFG is a square, we can label the sides DE and FG to be 6 units each, and we can also state that the angle AED and GFC must both be 90 degrees. Next, we can see that angle BAC and angle ACB adds up to 90 degrees. That is the red angle and the green angle. Therefore, the angle FGC must be equal to the red angle because it would also add up to 90 degrees with the green angle. So we can state that triangle AED is similar to triangle GFC by the AA test. So using the ratio of corresponding sides for similar triangles, we can see that FC over DE must be equals to FG over AE. And we know 3 of them, so we can find out the 4th one, which is FC. It would be 9 units. Next, we can just work out the area. So there'll be the sum of the areas of 2 triangles plus a square. And when we compute that, that will be 75 units. Question 13. Anthony, Judith, Daniel, and Edward were born in 1975, 1976, 1977, and 1978 in the cities of New York, Moscow, Barcelona, and Singapore, though not in that order. It is given that the person born in Barcelona is 1 year older than the one born in Singapore. Edward was born 1 year later than the person born in Barcelona. Daniel was born in Moscow, and Anthony was born 2 years later than Edward was. Which year was Judith born in? Pause the video here and give this question a good try. So for question 13, we're going to turn these clues into mathematical statements. So from the first statement, we know that the birth year of the person born in Barcelona is equals to the birth year of the person born in Singapore minus 1. From the second statement, we can see that the year in which the person born in Barcelona, his birth year, will be equals to Edward's birth year minus 1. From the first 2 statements, we know that Edward must be born in Singapore. The third statement we will skip, that's just very clear. And in the 4th statement, we can see that Anthony must be equals to Edward's birth year plus 2. So using the clues that we've gathered so far, let's construct a table. So the columns will represent the birth years, while the rows represent the cities that they were born in. We know that Edward is born in Singapore. We know that the person born in Barcelona is 1 year earlier. And we know that Anthony is 2 years later. But that must also mean that Anthony is 3 years after the person born in Barcelona. That must mean that the 3 years age gap, there's only one possibility. So the person born in Barcelona has been born in 1975, and Anthony has to be born in 1978, and Edward has to be 1976. So let's use this data and fill in the grid. Well, let's put in the Barcelona first. Barcelona is 75, so we can gray out the rest of the cells. We know that Edward is 1976 and in Singapore, so we can gray out the rest of the cells. We also know that Anthony has to be in 1978. But we also know that Daniel is born in Moscow. So Anthony can't be born in Moscow, so Anthony has to be born in New York. That leaves Judith to be born in Barcelona, and that's our final answer. Question 14. A convex polyhedron has 48 edges. Its faces are either quadrilaterals or hexagons. Each vertex is an endpoint of exactly 3 edges. How many faces does the polyhedron have? Pause the video here and give this question a good try. So for this question, we'll need to use a formula called Euler's characteristic. So first thing we know is that this polyhedron has 48 edges. Now for any polyhedron, every edge would have 2 endpoints, and each endpoint will be a vertex. But each vertex in this question has 3 edges. So we can calculate the number of vertices. That will be the number of edges times 2 and divided by 3. So a total of 32 vertices in this polyhedron. Then Euler's characteristic states that the number of faces is equal to the number of edges plus 2 minus the number of vertices. So that will be a total of 18 faces altogether. And that's our final answer. We have come to the last question of today's video, question 15. In the diagram below, ABCD is a parallelogram. Angle ACB is equals to 90 degrees. M and N are on the sides AB and CD respectively, such that the ratios AM to MB is equals to the ratio CN to ND and is equals to the ratio 1:3. Given that AC equals to MN equals to 2 units, find the area of the parallelogram ABCD. Pause the video here and give this question a good try. So for question 15, we first recognize we have a pair of congruent triangles shown in blue and yellow. So these two triangles are congruent because of the ASA test. We can show that AM is equals to CN. They are both 1/4 of the length AB and CD respectively, and those are the two parallel sides of a parallelogram. Next, we can show that angle XAM is equals to angle XCN. This is because of alternate angles. Similarly, for the other pair of alternate angles, we have XMA equals to XNC. That means that point X will be the midpoint of AC and MN respectively. That means the sides of the two triangles will be 1, 1, giving us 2 isosceles triangle. And because the blue triangle is an isosceles triangle, we can bisect the triangle shown in green, and that midpoint will be Y. This will give us the ratio of AY to YM to MB to be 1:1:6 respectively. So I've labeled it as A:6A. Now we recognize that we have a pair of similar triangles. So triangle AYX is similar to triangle ACB. We can show this using the AA test. We can see that both triangles are right-angled triangles, that's given, and they have a common angle at A. So using the ratio of corresponding sides for similar triangles, the ratio of the base to the hypotenuse for the two triangles will be A/1, and the other one will be 2/8A. We equate this and we solve for A. A will be 0.5. Then using Pythagoras theorem, we can find the length of BC, which will be the square root of AB, and AB is equals to 8A, which is 4. So 4 squared minus 2 squared will give us 2√3. So the area of the entire parallelogram will be just the length BC times the length AC. That would be 4√3, and that's our final answer. We have come to the end of this video of Part A of the SASMO 2020 Sec 3 walkthrough. Part B has already been uploaded in the channel, so do check out the channel for more Olympiad videos. Anyway, thank you and have a great day of learning.